All right, pre-calculus guys, here we go. I'm going to go back over functions. We're going to finish this up, and everything's going to be fantastic. All right, so just to remind you, a function is a relation. It's comparison, comparing one set to another set after something happens to it, some sort of mathematics, some sort of function that's given there. All right, this is one set, and each member of the set compares to only one other value. So set A and set B, we see that there's only one arrow coming out of a number from set A. If there had been something different, like two arrows coming out of 2, then we would say that's not a function. But since there wasn't, since we originally had just the one arrow coming out of each, yes, this is a function. This is not a function. Here's your simple input-output table that you've been using for ages. Every member of x, there's a repeat. 0 repeats, and there are 2 separate values for that 0. Therefore, it's not a function. All right? We can also look at graphs, and we can use what is called the vertical line test. If you take a vertical line and go across a function, if it only crosses in one place, then we have a function. So this is a function. Down here, underneath, you see this vertical line cuts in two distinct places, there, and therefore that's not a function. Now we know what a function is. We have to start looking at function notation. Function notation is f of x. For our purposes, when we were little kids, we said, well, f of x is y. All right, we have a different function, g of x. We'll still say, if we're only looking at that function, we'll call that y. So there's input is x, and output is what you get when you perform the function. Here it is. All right, so we have a function of x is x cubed minus 3x squared minus 2x plus 6. There's a function for you. And here we go. Here we have what is this function if I input 4 for x. That's why there's the 4 inside that parentheses. And what we do is we substitute 4 every time we see an x, right? Okay? And then we just perform the operation. 4 cubed is 64. 3 times 4 squared is 48. And then 2 times 4 is 8. And we just bring the 6 down. If we do all this math, we get 14. Last but certainly not least, we've got to talk about domain. Sometimes you're given a function where there's an unreal or undefined answer for what you've substituted for x. And remember, when we have a function here of the square root of 2x minus 2, remember we can't have a negative square root. That's not real. We can start talking about imaginaries, but when we talk about imaginaries and we're looking at graphs of functions, those imaginaries don't appear on our calculator. So for our purposes in this class right now, we're going to talk about a domain that can't have a negative square root. There are other functions that are fraction functions, and we don't want a denominator of 0. But for right now, let's just talk about this function here. Function, we need to look for any values that will give us a negative square root. Well, if we have the number 1, we're okay, right? Because the square root of 0 is 0, right? And so anything where x is greater than or equal to 1, we're good. But once we go back from there, if we go to a half, 1/2 times 2 is 1, 1 minus 2 is negative 1. Now we've started moving into the realm of undefined. So, x has to be greater than or equal to 1. So we're going to write our domain in set builder notation. So a set of x where x is greater than or equal to 1 and x is an element of real numbers. There we go. That's how we do it. The last one I want to talk about real briefly, and I'll make a real simple function here. Let's say a function of x is equal to x squared minus 1 over x plus 2. There's only one value right there that will give us 0 as a denominator. So we say that x cannot be negative 2. And then if we wanted to write it in set builder notation, we would say a set of numbers x where x does not equal negative 2, comma, and x is an element of all real numbers. All right? And that's basically it. Now we're finished with this simple look at functions, except for, sometimes you're going to have a function that says, if your input is this, or this, or this, you can do that on your own. It's part of your work. You can handle it. Other than that, you've really created a simple base for what we're going to do next, which is just analyze these functions and make sure we understand how everything works.